So hello, my name is Jukka Asikainen, and as Joni said, I'm going to talk you how we moved the data flow of one of our customers into the cloud and using OPC UA. First of all, as Prosys, we specialize in the data handling in industrial automation using mainly OPC UA. And in a sense, if you want to make any decisions based on the data on the floor, you have to somehow aggregate that data and then transfer it onwards to some system, manufacturing, execution system, or enterprise resource planning system, etc. And we do those with Java with multi-platform capabilities. So here are some of our products which we offer, and we offer development tools. If you want to develop your own OPC UA application using Java, then we offer a service development kit for that. And then we have our own applications which are built on top of that SDK. So the historian aggregates several other OPC UA servers into one and also provides history data. So if you, for instance, have only the current values from the servers, then the historian creates the history using those current values. And then there's this Modbus server, which transforms Modbus devices into an OPC UA server. So you can access Modbus devices using OPC UA client. Then there are some free tools, OPC UA servers and clients for the desktop and Android. We are also a reseller of unified automation products. For instance, the OPC UA gateway can be used to transform the classic OPC to OPC UA. We also offer some services like OPC UA Quick Start, some workshops, and we do custom system integration as needed. Also want to mention the workshop, which gives a complete view of the OPC UA and how to use it, how to use OPC UA in your current case or in your own case. Then our case. All in all, the wastewater treatment plant is a large plant which has multitude of processes which all need to be optimized and monitored as a whole. And our customer provides software, this STAR online control system, to do that. And to simplify it a bit, only from the data point of view, what is needed by our customer. They need to get all the measurements from all those processes for analysis and then set the control set points back to all those processes after analysis. And in their case, there are 5 to 1,000 variables and control cycles around 30 seconds. This sounds pretty doable, I think. But one might even ask, are there any issues here? When you deploy 100 facility installations, all with the full analysis and control systems, then it becomes quite a lot of work to maintain, upgrade, and also troubleshoot all these facilities. And for this, they approach us. And indeed, there is a more cost-efficient, easier way. Next, I'm going to go through the cloud architecture in small increments, which we used in this case. So the architecture which we chose was so that the OPC UA clients are in the facilities and in the facility networks. And those OPC UA clients access the cloud network. So their responsibility is to collect all those measurements and write them to the cloud, and then read the set point values from the cloud and then set them back to the processes. And in this setup, only the OPC UA client is exposed to the public. So that is the only link to outside networks, and the facility network has no access to outside networks. Then on the cloud part, there are OPC UA servers, and their responsibility is to relay all those written values to the analysis engine, which is the Krüger part, and then publish those analysis results in the form of control set points in their OPC UA address space. And all the facilities have a single point of contact, which is the Amazon elastic load balancer. So we chose the Amazon as the cloud provider. And the load balancer also solves the scaling of this case, as we have Docker OPC UA servers running in Docker containers. So based on the load to this system and to the load balancer, it creates those OPC UA servers in the containers as needed. Or it creates containers which have these OPC UA servers. So it also solves the scaling problem. And this is the full view. So we have any number or large number of facilities which access the load balancer, and then based on that load, those containers are created as needed, and they provide the values for each of the facilities. That's it. Sounds simple. Well, how about the security? As the OPC UA servers are in public internet or in public networks, it might be a good idea to have some kind of security in place. Luckily in OPC UA, all the applications are first of all authenticated with public key certificates. So these certificates make sure that the applications are what they claim to be. And second of all, the traffic is encrypted with built-in symmetric encryption, which there are a few cases or a few options to use in the OPC UA specifications. So, as I said, only the trusted applications can have access to critical data in the OPC UA servers. And these certificates are created and handed by the Krüger for their customers. And we also built a small web dashboard which they can use to create those certificates and also to trust or to revoke all the connections and all the certificates which are connecting their OPC UA servers. So it's made quite easy to handle the security. All in all, before they had to do full deployments per facility, which when the number of facilities grew was starting to become quite a large amount of work. And after moving to the cloud system, they have only a single service to maintain, which is 24/7 online system in the Amazon cloud. All the connections are secured by those certificates, and also the traffic is encrypted. The architecture also solves the scaling problem using those Docker containers which run OPC UA servers. And the costs are, of course, directly proportional to the number of paying customers. And in the end, this has simplified the maintenance of a large number of their customer facilities. Thank you. Any questions? Jouni.
So how will you manage the address space changes, and how large is the address space? Do you have any examples about the instantiated address space?
There are as many variables as are needed per facility, so it might be 1,000 nodes, and it's part of their system that provides the address space for us. So we automatically generate the address space on the specs of our customer system, on the Krüger system.
And it's dynamic according to the number of facilities that are added to the system. And so.
Yeah, it is in a way dynamically generated, the address space. Yes.
I assume that with this number of containers, managing these certificates is also quite a challenge, isn't it? So you need, do you have additional tools to manage and monitor the certificates as such?
Yes, we do. So that was the web dashboard that I was talking about. We didn't take into account the distribution of those certificates. So the Krüger has to do that somehow themselves. They somehow have to transfer those certificates to the trusted customers. But after that, they have this web dashboard which shows each connection which has a certificate, and it shows there, and they can either revoke or accept the incoming connection. So they see every connection attempt there. Yes.
Yeah, hi. One quick question. Where is the OPC server physically located? So you have the DMZ network for the client, then you have the facility network, which I understand is the customer premises, and then what about the server itself physically?
It's in the cloud network, so it's within Amazon, and the code is within Amazon. Yes. Was that your question?
Yeah. But
okay.
Just trying to try to understand about the remote access for the OPC businesses. I mean, from my background, I'm more like a network guy, not the automation guy. So I'm trying to understand the concept behind. But yeah, so it's in the cloud, and then your clients will be located in the DMZ.
Yeah,
so
the clients
what you basically do is that you contact the server, and then from the server, then you get kind of the access into the facility network.
Yes. From the DMZ network, then you have access to the facility network, but not directly. So the OPC UA client is the only part showing to the outside world from the facilities.
Yeah, so the servers are in the public internet,
yes,
in the Amazon
yes.
public cloud service. And the clients are in the secure facility networks, but because of OPC UA security, the communication is secure over the public internet, and we can use the public Amazon installations. And the Dockerized servers are instantiated on the fly as necessary. They have a single point of contact but it's kind of scaling the server side as necessary by just instantiating new instances of the similar server. And this actually helps. I mentioned in the morning that one threat, security threat, is the denial of service attacks, and I think this design also helps to counteract with that, because a single server can be blocked by a denial of service attack here, but it doesn't matter because we can always instantiate new instances of the same server on the side. Well, we haven't tried it out yet, but I feel that this kind of architecture can also help.
And also in that case you have the whole Amazon Web Services security, which I think should be in good condition on how large and how many customers they have. They have systems available that, for example, limit the denial of service attacks. And they have to have systems in place for everything that they expose on that load balancer to the outside world. Yeah,
they are experts in this field, so we can trust them to do that
yes.
Thank you. Actually, this Amazon Web Service, it's probably located anywhere in the world. It can be located in Finland or USA or whatever, wherever it is. It's most likely like Azure. But anyway, that's not my question. So when we are making, let's say we are supporting many different clients, and we have single OPC UA server, and when we have lots of clients, probably this web service generates new instance to provide many custom client, right? So if we have different clients at different requirements, I mean some clients maybe something is available for that client, and some client may not need that. So do you have any these types of issue in that in that OPC UA server, because it's like a probably it's a copy of same server many to serve that client or balance the load, right?
Yes.
So
can I answer?
So
okay.
So is it like that, or?
Yeah, how it goes depending on the client connecting, different address space is shown. So all of the clients with their certificates are differentiated, and we know what kind of address space that exact client needs. So they have already solved this exact problem, that we only need to show a part of the address space for one kind of client. So no other customer should see anything else that their own plant. Okay. Yes. So this is solved. It was a good question.
Yeah.
Yes.
Thanks.
In the facility, you have the process control system, right? So everything's there, and what is in the cloud is just the analysis engine. And based on the analysis, you can influence the set points and send them back to influence the process, right?
Yes, that is correct.
Okay, so if you lose connection to the cloud, you can still run the process without any
yes.
loss.
So you probably need to have some kind of fallback system, I would guess, yes. In a case of, let's see, they have no network connections to outside world, I think they must have some kind of fallback strategy to not to let the whole processes go amok, yes.
Okay, yeah, but in any case, the maximum you could lose would be just the loss of the analysis.
Yes.
But the process itself would continue ongoing in the plant, right?
It would continue, yes.
Okay, yep,
yes.
Thank you.
On the DMZ area, OPC UA client, do you use different protocols to communicate with the process, or is it also OPC UA?
I think it can be many protocols, and this is actually not on our hands or not on our part, and I think it probably is quite, or it can be quite diverse based on the facility.
Okay, so you can...
It's in a way also their customers.
So you can integrate your OPC UA client to different protocols? You have some kind of
Yes.
software?
Yes, yes. It can be done with custom code to integrate the OPC UA clients. Yes.
Another thing, if the connection breaks between the Amazon cloud and the OPC UA client, do you have some kind of buffering of data? Or is it in the process side?
Yeah, I can't really answer that because that's part of the Krüger's customers, yeah. But probably, hopefully, something like that is in place. Because, yes.
Yeah, and OPC UA contains this kind of redundancy, or how to say, reliability issues built in, so that it has buffering, basic buffering built into the communication protocol. Yeah, if you lose connection, the server can resend information that was missed or keep buffers. The client applications decide how long buffers they want to reserve on the server side. And if the connection is lost, you can still recover from that short connection losses. If you need to recover from longer losses, then you can apply the OPC UA history functionality. We have customers that, especially for event information, they can, when they connect, they can ask for the history of the last hour or so, or the last day even, and then start collecting the events from that on. This is all built into OPC UA. Okay, I think it's time for the next presentation.